Right, okay, so an air conditioning system. We've got in the centre, so when you do your little diagrams that you're going to draw, we're going to have the control system. But we need to think about what's connected to it. Okay, so we've got fans for this air conditioning unit. I'm not going to try and draw what a fan looks like. We've also got some keys, some buttons. So there must be some buttons for the control, but there's also a little, well on this one, an LCD display. Okay, so I've got a display. What else must they logically be, even though we can't see it? Go on, Matt. Yeah, some sort of temperature sensor. Now, I said you've got a little bit of research to do. I don't want you to just say, oh, temperature sensor. I want to know what the proper name is. I'm not going to tell you what the proper name is. I want you to look that up. Okay, so when you do this task, there are going to be input devices, the sensors. So they're going to provide input. The buttons are going to be input. The display is going to be what? Input or output? Output. Okay, so I'm going to just draw an arrow going that way. Right, in terms of the fans, how are we going to control fans? Anyone got any idea how we might control a fan? Yeah, there's going to be some sort of motor, isn't there? So a motor somewhere. It might be a pump, I don't know, it depends what type of aircon unit it is. I'm not bothered about that. But we've got a motor, so we need to be able to control the motor, to turn it on and off. We might in a really fancy system be able to like alter the speed of the motor. Yeah, in a fancy one, Sean, yeah. I'm seeing you can press there. Alright, so what I want you to identify for the control systems you do, okay, I want you to identify the components first off. Okay, so just get yourself a rough diagram down between you. Alright, just say, right, well, what have we got here? Have we got what input stuff, what output stuff have we got? Then what I want you to do, I want a list of tasks, actions. Okay, what actions or tasks does the control system need to be able to perform? Okay, so for an air conditioning unit, you're going to, as a minimum, you're going to have some sort of on and off to turn the whole system on and off. But what else might we have? Think about what happens when it gets hot in this room. What happens? What does the control system have to do?
Fans heats up.
Yeah, so we need to turn the fans on. If we turn the fans on, what else? What other action do we need?
Fans off.
Fans off. So, okay, so an air conditioner is more than a fan though, isn't it? Okay, what else is an air conditioning unit doing?
Change the humidity of the air.
But it technically doesn't change the humidity of the air, does it? That would be a dehumidifier, wouldn't it?
Ventilation.
Yeah, he's venting stuff out, but right, we've got down as actions, on and off. Okay? This room can be made to go hot or cold. So what other actions have we must have? Yeah, heat on and heat off. Is that logical? I don't know how it works. I'm just surmising what it is. Just as when you do your control systems, you're not necessarily going to know exactly how it works, but you know what it must need to do. So you must be able to turn the heat on and off. What else must we be able to turn on and off? Is this room just either hot or mildly warm? What else can it be? Cold. So there must be some sort of like refrigeration unit, mustn't they? Okay, which we must need to turn on and off. I probably can't spell refrigeration, I should have put fridge. Can anyone think of any other off the top of their heads actions that an aircon unit's going to need to do? What about when I'm using the buttons? Obviously I've got an on-off button, but what else can I probably mess about with?
Temperature.
Temperature. Set temp, or it might be adjust temp. Depending on how sophisticated the unit is again. Okay? Right. That's just an outline, and this is what I want you to produce, an outline. But what I want is the detail of how do I control a monitor with a computer, a motor with a computer. How do I get temperature information into a computer? What is the proper set of devices that can do that for me? Okay, so when you put yours together, yes, I want a diagram, but I also want clearly what actions and what the input and output devices are that are being manipulated by the control system. Okay, if there's any feedback, remember I demonstrated yesterday with the web camera what feedback was? When we had the audio and it was like that. But if there's any feedback in the system, you need to clearly say that. So thinking about an aircon system, what's the feedback that's happening?
Room gets hot or cold.
Yeah, the room gets hot and cold. The sensor tells us what the temperature is. We make adjustments automatically. Yeah, we say, oh, let's put the heater on. Let's turn the heater off. Let's put the fridge bit on. Okay? Based on the temperature. So when we're talking about feedback, the input makes the control system make decisions. Those decisions will affect the environment, and then the input reads that environment and tells us what the change is. Okay? Right, I'll tell you about one more control system, just an anecdotal thing. When I was working at the Sulso Research Institute, they were working on something called hydroponics. Anyone know what hydroponics is? Nobody? That's growing plants without soil. So using like water with solutions in it. Okay? And they had a brilliant experiment that it was just coming to the end of its year run, this experiment, and they were growing tomatoes using just water and nutrients. And they had a control system that regulated the acidity of the water. So it could detect how acid the water was. If it was too acid, it would drop alkali in. Okay? Alkalis, like soaps and things. If it was not enough acid, it would drop acid in. Okay? And that was all done using a sensor, a single sensor that could check for acidity. Unfortunately, that sensor broke. And that sensor kept reporting to the control system that there wasn't enough acid in the water. What do you think happened?
Everything died.
Everything died because the control system went, right, okay, we need to put more acid in the water. The sensor kept saying, there is not enough acid in the water. So it emptied the entire acid tank. And it destroyed all the data for the whole year, which was quite amusing. And they didn't think of doing one simple thing. What could they have done to try and stop that happening, do you think? Multiple sensors. It's what we call dynamic redundancy. Okay? Do not trust one sensor. Have more than two. Why do you need more than two, do you think?
So you have more than two if one breaks.
No. Yes, Umar.
Just then you can compare and see it.
Excellent. If we have two and one says there's not enough acid, the other one's saying there is enough acid, who do you trust? Say you have three. And the reason they didn't have three is because they'd run out of money for building the experiment. They only had enough money for one sensor. False economy. But there you go. Right, okay, so I need you. Oh, let me stop the tape. Let me rabbiting on now.